In this video, we're going to use our example automaton for recognizing viable prefixes to introduce one more idea, the idea of a valid item. To refresh your memory, here's where we left off last time. This is the complete non-deterministic automaton for recognizing the viable prefixes of the example grammar. And using the standard subset of states construction, we can build a deterministic automaton that is equivalent to the non-deterministic automaton. So here's the deterministic automaton that recognizes exactly the same language. This deterministic automaton recognizes the viable prefixes of our example grammar. But now notice that each state is a set of items. So there's a set of non-deterministic automaton states in each of these states. And recall that what that means is that the non-deterministic automaton could be in any one of these states. And in particular, this state here is the start state because it has the item s prime goes to dot e. The states of this deterministic automaton are called variously the canonical collections of items or the canonical collections of LR0 items. If you look in the Dragon book, it gives another way of constructing the LR0 items than the one that I gave. Mine is somewhat simplified, but I think also a little easier to understand if you're seeing this for the first time. Now we need another definition. We'll say that a given item is valid for a viable prefix alpha beta if the following is true. That beginning from the start symbol, this is our extra start symbol, and by a series of rightmost derivation steps, we can get to a configuration, alpha x omega, and then in one step, x can go to beta gamma. And what this says is that after parsing alpha and beta, after seeing alpha and beta on the stack, the valid items are the possible tops of the stack of items. That this item could be the termination state of the non-deterministic automaton. A simpler way of explaining the same idea is that for a given viable prefix alpha, the items that are valid for that prefix are exactly the items that are in the final state of the DFA after it reads that prefix. So these are the items that describe the state after you've seen the stack alpha. Now, an item is often valid for many, many prefixes. So, for example, the item t goes to open paren dot e close paren is valid for all sequences of open parens. And to see that, we can just look at our automaton and confirm that if we see an open paren, remember this is the start state. So if we see an open paren, we take this transition, we wind up in this state here. And then every open paren we see, we just go round and round in this state. So if I have a sequence of 5 open parens as my input, then I'll have transitions 1, 2, 3, 4, 5, all looping in this state. And notice that this item is one of the items in that state, and that just says that this item is valid for any prefix, any sequence of open parens.